Hey everyone, good afternoon and welcome. My name is Mark Feit. I'm a principal software engineer at Internet2, and today we're going to give a little talk about something that we added to perfSONAR in the last release. It's part of the limit system. It's called priorities, and this is sort of an addendum to the presentation that we did a month or so ago, or I'm sorry, a year or so ago, which covers the limit system in detail. Do want to point out that this is kind of considered advanced material. Most of what I'm going to cover today is probably more of interest to perfSONAR administrators rather than end users, but that end users might find it interesting because it might be helpful in understanding some of the diagnostic information that comes back when certain things fail. So, having said that, we'll dive right in. So the agenda today, we're going to cover three things. We're going to do a quick recap of the limit system and what goes into the limit configuration file. Then we're going to talk about how priorities work, just some sort of logistical bits there. And we're also going to talk about what to put in the priority section of limit configuration, which is a new addition. So we'll start by talking about the limit system, just as I said before, a quick little recap. The original version of Know Your Limits, which we ran last year, is available on the perfSONAR Project's YouTube channel at the URL below. Much easier to find if you just go to YouTube and search for perfSONAR and Know Your Limits. It'll be the first hit. So if you're not entirely familiar with the limit system and you want to go back and review, that's a place to go look for it. As was covered in the original Know Your Limits, the configuration file for the pscheduler limit system lives in etc pschedulerlimits.conf. If that file does not exist, then no limits are enforced, and requesters can be allowed to do pretty much whatever they want. If there is a limit file that's in place but it's not valid, then the limit system will punt and say that you probably intended to limit something, so it's not going to allow anything until that gets straightened out. When you make a change to this file, it should take effect in about 15 seconds of a new file that's valid being installed. The limit configuration file format itself is JavaScript object notation, or JSON as some people call it. Actually, a lot of people call it. I'll spare you the details of what that is, because probably just about everyone on here is familiar with it. If you're not familiar with it, just go visit json.org. And you will get a nice one page with everything you need to know about JSON, because the format is actually that simple. If you have a limit configuration that you want to validate before you put it in place, pscheduler has a handy command called validate limits that you can use to check out whether or not the installed limits file is valid. And you just run pscheduler validate limits. And I show two examples here, one with the limit configuration being valid, another one below it with the limit configuration being invalid. You can also use this command to check the validity of any arbitrary file that you want, and we recommend that strongly before you install a configuration so that your production system keeps running. And that command is just validate limits with the path to the limit file added to the command line. Otherwise, it works the same way. There are some I'm sorry. I'll pause right here to take questions if anyone has any so far. Okay, well, hearing none, we'll press on. So next thing we're going to talk about is priorities, which is a new feature in pscheduler that was released with perfSONAR 4.2 recently. Priority as a concept is fairly straightforward. It's just simply it's an integer value, and higher values are given preference over lower ones. We have a nominal or a default value of 0. That may change at some point in the future. Probably won't, but it can change. But 0 is sort of our nominal default for that. And you can have positive values, you can have negative values, and when it comes to doing a comparison, the one with the higher value wins. Priorities get applied where you have two tests where runs can overlap. And probably the poster child for that would be throughput, because you don't want to run two of those at the same time. And throughput falls into a scheduling class that we call exclusive. And what that means is that run of that test gets the system to itself while it's running. That was a decision we made several years ago, mostly because we didn't want to do things like starve other tests for CPU, or sort of there's the obvious problem where you have two throughputs running and they're both competing for bandwidth on the interface going out of the system. There's also another test called idle EX, which is does almost what it sounds like it does. It does idle exclusively, and idle means that the system does nothing. That was something we wrote as part of the as part of the development process, just to exercise the infrastructure. But that is there if for some reason you want to do that. We have another scheduling class called normal, which the one-shot latency runs as, and you can run as many normal things as you want at the same time, and they won't clash with anything that's been scheduled exclusive like throughput. So those are really where you're going to find that the priorities are going to happen. Everything else is a background or a background multi-test. So background is things like round trip time or trace, and background multi are things like streaming latency. We differentiate between one shot and streaming latency because streaming we sort of decided we're just going to do them continuously, and if people see things like changes and like increases in latency, they might be able to go back and correlate it with a throughput test running. And people just felt that it would be more important to have it work that way. So all of those are not scheduled are not subject to priorities, and they'll be scheduled and run whenever they get run. So that's not too big an issue for those things. The priority of a test that's going to be run is determined as the runs are scheduled for them, and it happens in two phases. The first attempt is without any priority applied. So the idea is that if we can schedule around some of the other runs without having to preempt anything or be preempted ourselves, that's a much better outcome than just saying, okay, well, this is the first slot in this timeline where it fits, and anything else of lower priority, is just going to have to suffer. If we can't do it without the priority applied, then we apply the priority and we ignore anything of lower priority. And we schedule based on that. So it'll still try to schedule around things that are higher priority, but it will ignore the lower priority things, and they'll end up getting preempted. If neither of those is possible, the run becomes what we call a non-starter, and that's determined on each system involved. Now, usually, if you're doing something, well, throughput's actually a great example because it has two participating systems that have to put exclusive time on their timeline to do this. So the priority is determined by each system on each end. So you could end up with something on the sending system being high priority, and something on the receiving system being low priority, and the end on the receiving system becoming just not running because something else preempted it. What this means is that the lead participant may still run the sending end in the case of throughput, but it will become a failure because there isn't, in the case of, for example, iPerf3, there's no iPerf3 server awake on the other end to respond to it and run the test. We're looking at some different ways to maybe make it a little more obvious when that happens, so that when you see things that right now you kind of see things that are failures, and you have to figure out if they failed because of priority on the far end, or if it was because there was an actual failure. So that will probably be resolved in one of the next few bug fix releases. Once a run has been scheduled, it does not move. So what that means is that if something higher priority is scheduled at the same time, even if the lower priority thing could be shifted to another time, it isn't. There's actually quite a bit of development that has to happen for that to work. And we elected in this case just to keep it simple initially, and if we find that there's demand for more sophisticated scheduling, we'll start to take a look at that. Whether or not a run is preempted is determined at the time that a run is scheduled to start. What that means is, as I mentioned before, everything gets put onto the timeline, whether it's going to be preempted or not. And that way, if, for example, if you had a couple of throughput tests that overlap, and the higher priority one was removed for some reason, then the lower priority one would be able to run again because it becomes the highest priority one, the highest priority test that's going to run. So that happens. All the stuff gets put on the schedule, and it really happens sort of like in the few seconds before a run is scheduled to start. So I'll pause here again and see if there are any questions. Okay, well, hearing none, we'll press on some more. So the way you get priorities set up in pScheduler is you add, as I mentioned before, this all takes place as part of the limit configuration, and there's a new section in there called priority. And the way you add that is you quite simply add an object to the bottom called priority, and you set the schema up at the top to 3. That's a new version because priorities are new, and the older systems will not recognize the priority, and you'll get a warning that says, "Hey, this was schema 2 or earlier. I can't do that." This will apply on anything, any release of perfSONAR 4.2 or later. Should work no problem. We do ship a sample a sample priority setup in the stock limits file that we ship with the toolkit, and we'll actually take a look at the insides of that in a few minutes. So here's a kind of a skeletal version of what the priority section looks like, and it turns out that it's actually just a big JQ script. As some of you may remember, we use JQ quite a bit in pScheduler because it adds a whole lot of programmability at a fairly low cost. It's just a standard, what we call a standard pScheduler JQ transform. We have sort of a standard little blob of JSON for doing these. This is discussed at length. There is another presentation from a year or two ago on the JQ scripting language and how to use it in perfSONAR and pScheduler specifically. And you can find that just by searching YouTube for perfSONAR and JQ, and the first hit you get will be the presentation that we did on that. So the input for the script looks like this. It is just the test specification. So what you will get is you'll get an object inside of it called test that has the test type. You can see its throughput here. It will get the test specification, which is just all the commands for that particular type of test. So in this case, this is something fairly simple. We're doing a throughput test. We're doing it. The destination is ps.example.net, and the duration is 20 seconds. Down at the bottom, you'll see you'll see something else, priority, which is just an integer. This is optional. If it's present, or if it's present and null, I'm sorry, if it's present and it's not null, then it's an integer that tells what priority was requested when the task was submitted. These, by the way, are fully supported in psconfig, and also on the command line. There's a new switch called priority that you can use as part of the task command that will let you specify the priority on the command line if you wish. If priority is not present, or if it is present and it's null, then the assumption is that no priority was requested and the system will use the default. One thing you'll notice that's missing from this, there are no proposed times. And the reason for that is that we actually don't know what the times will be by this point. Part of that's actually something that happens later, and what you come up with for a priority actually affects when the run will be scheduled. So so we can't give you some idea what's being proposed for that yet. What comes out of the script needs to be exactly the same thing that went in. There is actually some hidden data that's used by some of the special functions that I'm going to show you in a couple of slides here. That hidden data must be intact when the script finishes. So my best advice to you is that when you're writing a JQ script for this, don't alter the input. We supply pretty much everything that you need to make decisions and to make changes to what the priority should be, and I'll show you that here in a second. We have a bunch of different functions available. These are special functions that are available just in these kinds of scripts. Actually, the two that I'm going to show you right now are actually available elsewhere, but you'll find these in priority scripts as well. The first is classifiers, and that simply just returns an array of all of the classifiers that the requests are met. So, for example, you might have one for research partners, or requesters that are on the local machine, or requesters that you know to be hackers that you don't like. Any of that sort of thing all falls under classifiers. How to determine what those are is covered over in the original full version of Know Your Limits. The second function we have available is called classifiers has, which is just sort of a convenience thing. You put in a string value, and it returns a Boolean that indicates whether or not the string that you passed in appears in the classifiers list. So for example, if you're looking to see if the classifiers has the friendly classifier, you can say classifiers has friendlies, and you'll get back a true or a false from that. You can use that for making decisions. There are three functions for getting values related to priority. The first one is default, which returns whatever the default priority is. Normally that's going to be 0, but please use the function because, like I say, I don't think we'll ever change it, but it's good practice to use that. And that way, if we ever do change it, none of your stuff will break. The second function that's available is called requested, and that will return the priority that was requested when the task was submitted. That value will be an integer, as described before. It will be null if no priority was requested. I've highlighted something really important here, which is that you want to make sure you test for null before trying to use the value. And the reason for that is that in JQ and probably in a few other places, if you try to do comparisons with null, you're going to end up with true, as is the case here. Null is actually always less than 1, 2, 3, 4, and you don't want to make the mistake of having comparing something that's always going to come out true if you don't necessarily want it to. This function is actually the equivalent of pulling the priority element out of the input. Please use the function. I don't anticipate that the input will change, but it's just good practice to do so. Finally, the third function that you can use for getting priority is priority, and that gets whatever the current priority is. That value is set to whatever default is when the script starts. So if you write a script that does absolutely nothing, you're going to end up with a priority of the default, and that will be the end of it. So that's the read part. Now we get into the write part. There are two functions for that. One is called set. They both work pretty much the same way. One is called set. It takes two arguments, value and message. Value is an integer that sets the priority absolutely to that number. So if you set the priority to 78, it's going to be 78 when that call to the function finishes. The message argument is a little piece of plain text that you can put in there so that the user, if they're looking at diagnostics, can figure out what it was that you did or why you did it. So in the two examples you can see below the bullet, you can see we do a set, and we do a set default, for example, and we say that's the initial priority. That's actually something you'll see in the stock limits file that we ship. The second one might be that we've made a decision, we've decided that the priority is going to be 100, and we do that for whatever reason we do it. And again, that just shows up in the diagnostics so the user can see them. The second function is called adjust, works a lot like the set function does. The only difference is that it takes the current priority and it adds whatever the value that you provide is. And that's just for making up and down adjustments and putting a message in the diagnostic output. So you can see down here at the bottom, for example, we adjust by -5, and we say, we just dislike you a little bit. And that will take whatever the current priority value is. So for example, let's say it's 10, you adjust it down by 5 and it becomes 5. Adjust it down by 5 again, it'll become 0. So that should be pretty straightforward, I think. Finally, there's one function to write things into the diagnostic output. This is really useful for debugging, but I suppose you could probably use it for other things as well. Just kind of a way to, pass whatever messages you want on to the user. And that just takes a message, and all it does is it just adds the message to the diagnostic output with no change in what the priority is. So what comes out of pScheduler, if you've seen the diagnostics for runs before, you can either see what happens with the pScheduler result command. There's a nice switch in there called diags that shows you all this stuff. But what comes out of the diagnostics from the limit system are what the classifications were, and that's always been there. And there's a new section down at the bottom that says we had a priority of, in this case, for example, -10 was requested, and it was set at -10. So the first thing we did perhaps in this one was we set the initial priority to 0. So at that point, the priority is 0. This next thing, which is crossed out, is actually something we took out in the 4.2.1 release that we just released last week. And that's for adding 5 priority points to friendly requesters. So in this case, if we were still doing this, and the requester was friendly, which you can see it was because it was classified as friendlies. And we'll look at the code for all this in a second. After that, the priority has become 5. Finally, because a priority of -10 was requested, and that's lower than what we actually had come up with by that point, we'll say, okay, they want low priority, we'll give it to them. So we set it absolutely to -10, and at the end there, that's what you get is a -10. And again, I'll show you the inner workings of that in a second. I'll pause here for questions if anyone has any. Okay, well, hearing none, we'll press on. So next, we're going to take a look at some examples of how all this is done. So we'll actually look at some JQ scripts that accomplish some of these things. I will note that the examples I'm going to show you are without the proper JSON escaping, because all this stuff is actually ends up as JSON, but I left the escaping out just for clarity so we can take a look at it. There are plenty of good examples of what the proper escaping is in the stock limits configuration that we ship with the toolkit. I would also recommend, but we don't require this, it would also be a good idea to use the configuration that's shipped with the toolkit. There's kind of a top and a bottom half. We'll talk about those in a second. But it's a good idea to use that as a base for standard behavior. And we'll take a look at what those are right now. So this is the top part of the configuration. And I always like to start my JQ scripts with a dot, which just takes the input and does nothing with it. And I kind of do that for readability because I like to have all this stuff with the pipes lined up and things like that. It's just kind of one of those OCD things. So you can see that the next statement is a set, and that's where we set up the initial priority. I like to do that even though at the start of the script the priority was already set to default. It's nice to put that in there so it's in the diagnostic so that people can see what's going on. The second statement, the if that's below it, and again I have this crossed out because we stopped shipping this in 4.2.1 until we come up with a resolution for a couple of small things that came up as a result of it. But in this case, you can see we make a decision. We say if classifiers has friendlies, then we do an adjust of 5, and we say it was a friendly requester. This again is what was crossed out in the previous example that I showed you a few slides back. Otherwise, we just pass the input along and we do end. Most of your priority adjustments are probably going to be a variation on this if statement. Probably most of them will probably either have a set or an adjust as the then clause, and the complex part will get to be what's in the if condition, depending on what you want to do with it. So this is the bottom half of what we ship with the toolkit, and I really recommend putting these at the bottom of your priority script, because it will do some of the things that we showed earlier. We talked about earlier. So in the first case, the first statement, we go to force a lower priority if it was requested. So that was what we showed in the previous example, where the requester had said, I'd like -10, even though the priority calculation up to that point said said +5 or +10, however it came out. We're going to give them a lower priority. So this is fairly straightforward, but it's a little more complicated than the last one. It just has an and instead of just a single condition. So in this case, we say if requested is not equal to null, which means they actually requested something, and that goes back to what I talked about before about checking for null, and the requested priority is less than the current priority, then we set the priority to whatever was requested, and we say, well, they requested a lower priority, so that's why you got that. The second if statement here is even more complicated, but it kind of follows the same pattern. And this is to allow forcing of a higher priority if it was requested, if it was above the default, and if it was, if it was above the default and the current priority, and the requester has permission to do that. So again, we check to see if requested has even been done. So if they have requested something, then this will come out not null, of course. And if the requested priority is greater than the default, and it's greater than whatever the current priority is, and finally, so we're into a whole bunch of different conditions here, And in this case, they've passed a classifier called priority positive. Um, there's a provision you can put that you can put you might be able to say that hosts on our networks, for example, can be priority positive, so they can ask for priorities greater than 0. In a lot of ways, this is actually like the Unix nice model for processes. But finally, if all of that has been passed, then we set the priority to whatever they requested, and we say higher requested priority. Of course, we do it with the without the missing quote mark here. Not sure where that went. Otherwise, we just pass the input on, and that's the end of it. You can also do things by picking stuff out of the test specification. For example, if in this case we want to prioritize tests that go to a particularly important host that we have. So here's a real simple thing. We just we look at the specification for the test, and we say if it has a destination that is some important host .example.net, then maybe we give them a bump of 20 in priority because it involves that host. So again, all the decision making is fairly straightforward. It's all just based on the input, and you can implement whatever policies you like by doing that. Here's another similar one where we deprioritize long throughput tests. I'm going to gloss over this import a little for a second because I have another slide on it. But suffice it to say that we're using this to import a function that we use further down in the if statement that you'll see here in a second. So in this case, we take a look at the test type and we say if it's throughput, and they have specified a duration, and we call this duration a seconds function on the duration of that's in the test spec. And if that number comes out greater than 60 seconds, that's what the ISO duration of seconds function does, is it takes the ISO 8601 format of a duration and it converts it to an integer so you can do comparisons on it. Anyway, if all that is true, then we drop the priority by 10 because it's a long throughput test, and we want to give shorter ones the ability to run if there's contention for time in the schedule. So the JQ library that I mentioned a second ago is accessed using a JQ statement called import. And the way you do that, all of our pscheduler things are under a directory called pscheduler, so it's just import pscheduler / whatever module you want, and then you give it a namespace. So in this case, we said as ISO, and if we look back on the previous thread here, you can see that we said ISO : duration of seconds, and duration of seconds is one of the functions that's in that module. We include it's a very small library of JQ functions. There are actually only 2 modules in it. There's ISO 8601 that does things with ISO 8601 times and durations. There's another module called SI that does things with SI units. It'll format numbers to SI numbers and vice versa. That's probably something you won't have to use here because everything that comes into the system, for example, if you're looking at bandwidth for a throughput test, that will actually already be converted to an integer, so you can just simply do the comparison against the integer. All of that documentation for right now lives on the documentation for all that lives on the pscheduler wiki, and you can get to that actually if you just go to our GitHub page, and there's a page on there called JQ pscheduler library that has that. At some point in the near future, we'll probably get that migrated into the official documentation so that it's easier to see and easier to get at. So that was actually pretty much all I had for this. It's like I said, it's kind of a short addendum, and I do see I still managed to chew up a half an hour on it. If anyone has questions, I'll be more than happy to hang around. If not, thanks for coming. This will be available on our YouTube channel probably sometime in the next week. If you need to go back and take a look at anything else. So if anyone has questions, please feel free to unmute and chime in. Aha, we have something in the in the chat here. Let's see. Ah, okay. Nope, no questions from Matt. And I guess hearing none from anyone else, we'll close up then. If you come up with questions later, please feel free to post, by the way, on the perfSONAR user mailing list if you're a member of that, and we'll be more than happy to get your questions answered. So again, thanks for coming, and enjoy the new feature.